over oceans, water sometimes moves circular like this. This circulation is called eddy currents. So what is important for doing this? We need to determine some parameters for eddy currents. If I have computed the geostrophic flows for U and V, I can define this second order derivative. So let's see, G11 is the derivative of this north-south component with respect to X. And the XYZ is a local XYZ is local coordinate system. G12 is derivative of U with respect to Y, and G21 is derivative of V this time with respect to X, and G22 is derivative of V with respect to Y. So, I mean, we take the derivative of geostrophic velocity component was X and Y, each one of them. And based on these derivatives, I can define new parameters for the first one is vorticity. The second one is shearing deformation, and this one is stretching deformation, and the last one is divergence. So what does that mean? If, for example, we can compute a positive or negative stretching, for example, I'm talking about this one, stretching, indicate extension or contraction or compression in northwest component. So you can compute this thing. You can compute this G numerically from the geostrophic velocities that you have determined, or if you want to determine a better model for that, maybe you have to estimate it by least square. We say that, okay, the geostrophic flow plus an error that I had on the geostrophic flow plus an error. And we write an equation. This is a simple equation of motion. So I said that x1 minus x0. X0 is the center of the geostrophic flow. If geostrophic flow is x1 and y, x0 and y0 is the center. Plus G12 yi is 0 plus UC. And I can write this. What are the unknown parameters? The unknown parameters is this one, is 0. The center of the rotation, G1, G12, G22, G2. The acceleration, and this is the velocity. So if you have geostrophic flow, for example, from the maps, or you can compute this one, you can have this geostrophic flows from altimetry data over this one, and you can fit this mathematical model. You have an observation equation, and the observations are this one. From where they come from? Sea surface anomaly. When you compute these things, computed this one, you can put them here, and you can perform a least squares estimation. It's a nonlinear equation, but you can linearize it and solve it suitably. That's well known in geodesy. We know it. So you can estimate this kinematic properties of geostrophic flows. So this, if you see maps over ocean that's showing such circulation of water here, and actually they have performed something similar to this process. We're coming to this. It's run for Eddy's kinematic models.